This is Unit 2, Lesson 4, Domain and Range. The domain and range of a function. Because functions convert values of inputs into values of outputs, it is natural to talk about the sets that represent these inputs and outputs. The set of inputs result in an output is called the domain of the function, and the set of outputs is called the range. It's important to know that the set of inputs that are allowable, and this will make sense in a little bit, but you just need to know that not every input could be the domain. So exercise 1 says consider the function that has its inputs the months of the year and as its outputs the number of days in each month. In this case, the number of days is a function of the month of the year. Assume the function is restricted to non-leap years. Write in roster form the set that represents the function's domain. So it says right here that the inputs are the months of the year. That's what your domain is. Your domain is inputs. Roster form is just a list form. Okay, it just means a list. So I'm going to put D. Always when you're identifying the domain, you put D colon, and then I'm listing the months of the year. So January, February, March, and so on until you get to December. We always put these brackets around as well. It's important to note that many times you can't put things into roster form simply because there's too many things to list, so it's not feasible for that. Now it says write in roster form the set that represents these functions' ranges. So that's the output. So the output is the number of days in each month. So then I'm going to look here. What are the possible days in each month? Always start from your lowest number to your highest number. So my range, well, February has 28 days. So 28. Then we have months that have 30. And then 31. So that would be your range, your list of your outputs. Exercise 2 states the range of the function and range in the mapping diagram below. So we talked about roster form. Now we're going to be talking about mapping. Mapping is just these circles. We kind of discussed it a little bit, touched on it a little bit in class. So we are finding the range of the function f of n equals 2n plus 1 if its domain is a set 1, 3, 5. Show the domain and range in the mapping diagram. So first thing I need to do is I know my domain. It's given to me. It's right here. I'm going to put in the domain circle 1, 3, 5. That's my input. I already know what my inputs are. So now I have to find my output. So I have to plug those in for n in the function of f of n to find my range of f. So I have 2 times 1 plus 1, which gives me 3. So that will be my first one. Then I have 2 times 3 plus 1 gives me 7. And then 2 times 5 plus 1 gives me 11. So it's important to know that your input is your domain, your output your range, of course. So when I input 1, I get the output of 3. When I input 3, I get the output of 7. And when I input 5, I get the output of 11. So this would make my range the set of 3, 7, and 11. Again, this is the mapping diagram. exercise 3, the function y equals g of x is completely defined by the graph shown below. Answer the following questions based on this graph. Determine the minimum and maximum values represented by the graph. So remember, minimum is the lowest point. So in this graph, my lowest point is here. And so that would be my minimum. This is the x values. So I am looking for the x values. So this right here is x value of 3. So my minimum is 3. Then my maximum is right here. So my maximum is 6. Then it says, determine the minimum and maximum y values represented by the graph. So my y value is you're looking down. So we looked across before, now we're looking down. So my minimum is going to be -5, and my maximum is going to be 4. Now when you scroll down a little farther, it says state the domain and range of the function using set builder notation. This is a new notation that we haven't talked about, so just follow along. This is set builder notation. So my domain is all values such that, and I'm looking up here, so what is my domain? My domain is my x's. So if I were to scrunch that graph into a straight line towards the x-axis, so if I was to get rid of this, if I was to take this and scrunch it this way, where would it hit? Well, it's going to hit in between these lines. So what is that point right there? That is -3, and this is +6. So my domain is anything in between here. So when you write it, you would write it as domain is all the values of x such as, so my minimum is -3, and it has to go greater than that. So I'm going to have less than or equal to x, which is less than or equal to 6. Because that means your domain is all your points in between -3 and 6. So all your x values between -3 and 6. Now we're going to find our range values. So you're going to write it just the same way. You're going to say range is the values of y such as, what is my minimum for y? We just said it here. When you're looking at range, you're going to look and draw your, excuse me, that was domain. You're going to draw your points, your high and your min for your y value. And it's like you're scrunching everything in towards the y-axis. So if I scrunched everything in, where would that y value hit on my y-axis? So of course I have my min, which is -5, and my max, which is +4. So how I write this, domain is all values such as y such as, well, my min is -5, less than or equal to x, which is less than or equal to 4. So that's saying, and this should actually be y, that's saying that my y values have to be between -5 and 4. I can include it because it's a closed dot. It has to be between those points. It's important to know that set builder notation, you need to say it or write it. It's domain or range is all values of, and it'd be x or y depending, such as. That's how you say this set filter notation. Okay, so it's important to know that the last exercise we did, there was a definite stopping and starting point for their domain and range, but some functions defined with graphs or equations have domains and ranges that stretch out to infinity. Consider the following exercise in which a standard parabola is graphed. So the function f of x equals x squared minus 2x minus 3 is graphed on the grid below. Which of the following represents its domain and range written in interval notation? So we're looking at this and it's saying we want the domain and the range. So first let's just look at the domain. That's the first thing. Look at one at a time. And if I were to bring this graph so if I stretch this graph out, notice that we have arrows here, so that means it's going to just keep going on forever. So the graph will go up this way, but if I think about it stretching it towards the x-axis, it's going to hit all x values. So it's going to negative infinity and positive infinity. So I'm going to look here to look at my domain. Right here, I only have one option, but I need to make sure my range fits as well, because you can't just assume that you got the domain so the range is correct. Maybe we made a mistake, so it's always important you double check. So my range, I'm looking for my minimum, so what's my lowest point it hits? Right here. So that's -4, and it goes up. It's extending, there's arrows, up forever, so it goes to infinity. Now, notice that we have different types of brackets. If you have a boxed bracket like this, that means it's a definite point. That point is included. So the point is included. If you have parentheses like this, that means the point is not included. For most functions defined by an algebraic formula, the domain consists of the set of all real numbers given the concise symbol. And this symbol did not show up here, so if it's not on your packet, you just need to make sure the symbol, you have 2 lines like this, and then your R. It's all real numbers. Sometimes, though, there are restrictions placed on the domain of a function by the structure of its formula. 2 basic restrictions will be illustrated in the following few exercises. So exercise 5, the function f of x equals 2x plus 1 divided by x minus 4 has outputs given by the following calculator table. So the first thing, it says A, evaluate f of 1 and f of 6. So I'm going to go to where f of 1, so x is 1, and then where x is 6. So what is my f of x equal? What is my output? I have -1 and 6.5. Why do you think the calculator gives an error at x equals 4? So right here, why do you think it gives an error? I want you to think about that. Jot down your answer, why you think it might. And I'm going to tell you. The 4 is not in the domain. Can't come out in the input because of this reason. So if I have f of 4 and I plug it into that formula, 2 times 4 plus 1 divided by 4 minus 4, I would get 9 divided by 0. If you remember in Algebra 1, we cannot have our denominator as 0. That means it is undefined. So you cannot divide by 0. If you need to put this as a special note, you cannot divide by 0. It is a no bueno. That is why it says error. Are there any values except x equals 4 that are not in the domain of f? Explain. Well, the answer would be no, all the other values are fine, because 4 is the only one where if I take x minus 4, I would get 0. So you can just say all other values are fine. Exercise 6, and the last one for today. Which of the following values of x would not be in the domain of the function y equals square root of x plus 4? Explain your answer. So I'm going to just plug in each one of those values to see if you get an answer. So I have, if x equals 0, I have square root of 0 plus 4. 0 plus 4 is 4, so square root of 4 is 2. So that checks out. Let's try x equals 5. Square root of 5 plus 4 is the square root of 9, which equals 3. That checks out. Let's try negative 3. Square root of negative 3 plus 4 equals square root of 1, which is 1. And that checks out. And negative 8. Square root of negative 8 plus 4 gives me the square root of negative 4. Now, right now, you cannot take the square root of a negative number. That will come a little bit later in class, which is called imaginary numbers. But right now, you cannot take the square root of a negative number. So negative 8 would not be included in the domain. I want you to look through the video, jot down any questions you might have, and be ready to come to class and ask them. Have a great weekend.